In increasing measure, modern companies need computer technologies which optimize information flows. They want to convert the available knowledge into strategic information. Syllogic, a Dutch company based in Houten, supplies both the technology and the solution for this. Its activities include the analysis of information problems in an organization, consultancy, constructing and structuring databases. Syllogic has developed a number of highly specialized tools. Knowledge engineering solutions at decision-making level, graphical interfaces which provide a visual translation of the available and required information, scientific models which visualize information and information flows. By using Syllogic solutions, management at every level obtains an understanding of the business situation. On this basis, managers can take strategic decisions of high quality and reliability without losing sight of the human factor. Syllogic analyzed and built a pilot's career planning system for the Royal Dutch Airlines, KLM. Automated career planning systems tend to be complex because of large numbers of quantitative and qualitative constraints that dominate the problem space. Taking into account the collective labor agreement regulations, commercial planning data, the availability of flight simulators, and the selection behavior of pilots, individual plans are worked out for thousands of pilots for a period of 10 years. The new system automatically exchanges data with a number of other computer systems. Using techniques from operations research, knowledge engineering, and machine learning, the system calculates and displays the effects of employment, service, economic developments, and the required investments. All these data are displayed graphically on interactive screens, providing an exceptionally powerful tool for management in determining its long-term and short-term strategies. Here we will focus on one aspect of the application, the prediction of pilot bid behavior. Suppose you're a young pilot called Janssen. In 1984, you apply for a job at KLM and you start in one of the lower seats. A seat is a certain function for a certain aircraft type, for instance, second officer on a Boeing 747-400. At the start of your career, you get a seniority number. This number determines your position in the career hierarchy. The longer you work for the KLM, the higher your seniority ranking gets. Pilots with a higher seniority have more rights than pilots with a low seniority. Here we see a representation of Janssen's function. Of course, you don't want to stay second officer forever. You want to end your career as a captain on a 747. Unfortunately, you have a long way to go. KLM has determined a limited set of career paths for you. You can make the transition to second officer 747-300, but then you have to stay in this seat for 6 years. This time is called commitment period. Or you can make the transition to First Officer 737 with a commitment period of 2 years. A transition to First Officer 747-300 with a commitment period of 6 years. Or a transition to First Officer 747-400 with a commitment period of 6 years. This is a simplified overview of Janssen's career possibilities. Twice a year, Janssen can bid for new career moves he would like to make. In general, you can make a transition only if 3 conditions are satisfied. You must be free of commitment, you have made a bid for the seat, you must be the most senior officer applying for the transition. By defining commitment periods, the attractiveness of certain transitions can be influenced. For instance, the transition from Second Officer 747-400 to Second Officer 747-300 is unattractive because it has a commitment period of 6 years and it doesn't bring you any closer to your final goal of being a captain. you must realize that making the right choice is very important for your career. There can be dramatic differences in earnings between pilots that started with equal opportunities in the beginning of the 70s but made different choices. So, you choose to become a First Officer 737. After you have been a First Officer 737 for 3 years, you bid for 3 seats: First Officer 747-400, First Officer 747-300, and Captain 737. The planner chooses to put you in the First Officer's seat at the 747-400. After 3 years, it's time for you to become a captain, so you bid for the captain's seat at the 737. You are assigned to this seat for 3 years. Then you bid for the captain's seat at both the 747-300 and 747-400. The planner assigns you to the 747-400, which is what you wanted for all those years. Because of the time reaction lag effects, the planner has to anticipate bid behavior of pilots in advance. If a Captain 747-400 retires, he needs to be replaced. Normally the vacancy will be filled by a pilot with lower rank. For instance, a First Officer 747-400. In the worst case, this can lead to a chain of 7 vacancies in the careers ladder. So we have 7 transitions and 7 pilots must be trained. This leads to a time reaction lag of almost 2 years. The planner has to anticipate changes in bid behavior 2 years in advance for 1,200 pilots. So there's plenty of reason to build an automated tool for supporting the work of the planner. When Syllogic started to work on the captain's implementation, it soon became clear that prediction of the bids of individual pilots was a necessary condition for creating reliable short-term plans. We evaluated 3 possible technologies to solve this problem: operation research, rule-based reasoning, machine learning. Operation research was ruled out because it mainly deals with quantitative data, but our domain has a lot of qualitative data. Rule-based reasoning was ruled out because the planners lacked systematic knowledge about pilot bid behavior. We decided to set up some experiments with machine learning techniques. We executed 2 tests with machine learning techniques, one using neural networks and another using genetic algorithms. We used historical data of pilot bids from 1986 to 1991. Both tests were successful, providing a forecast that was correct in more than 80% of the cases. In the end, we decided to implement the genetic algorithm in the final version of Captains for several reasons. The rules produced by the genetic algorithm were fairly readable. It was possible to mix the rules produced by the learning algorithm with user-defined rules. The basic idea behind the genetic algorithms is that of Darwin's evolution theory, that is, natural selection and survival of the fittest. The bid prediction algorithm in Captains has 4 stages. Data collection. The algorithm analyzes the historic career information and creates special career descriptions. Rule transformation. The career descriptions are transformed into rules. There is a rule for each career. The learning stage. 100 generations of rules are tested to find an optimal rule set. Prediction. New bids for pilots are predicted using the rule set that was learned. First, we start with the data collection. Do you remember the career of Mr. Janssen? Here you see a schematic representation of Janssen's career, which represents both information about his functions and about his bids. A career description can easily be transformed into a rule, predicting exactly the last bid of a pilot, given his previous career. In this way, we can make a preliminary rule out of the career of each pilot. but of course these rules are much too specific and may not apply to other pilots. What the genetic algorithm tries to do is to mutate these rules randomly, hoping to get better rules that predict behavior of more pilots. This is done in the following way. Each individual rule is tested on the whole of the historic data. If a rule makes a right prediction, it gets a bonus. If a rule makes the wrong prediction, it gets a malus. If a rule does not apply, nothing happens. Each rule is tested on all careers. In this way, we get a hierarchy of rules. Rules that are very strong, of high predictive power. Rules that are very weak, of low predictive power. Rules with a low predictive power are the ones we don't need in our sample, so we can throw them away. But of course the rules with a high predictive power may not be the best rules that exist. Therefore we try to change them at random, just like the process of mutation in the evolution theory. There are various mutation mechanisms. Shortening of a rule. Shortening of a rule makes a rule more general by ignoring information of the past. Entering wild cards in a rule. This operation makes a rule more general by ignoring information randomly. Crossover of rules. The crossover operation combines two rules into a new one. We apply these operations at random to the most successful rules and then replace the least successful rules by mutants of the more successful rules. In this way we get a new generation of rules. This new generation may be more successful than the old one. From this stage on, the process repeats itself. In this way, the current captain's bid prediction algorithm creates 100 subsequent new generations. Tests have shown that the resulting rules in most cases predict the pilot bid behavior correctly in about 80% of the cases. The captain's system has been in full operation since March 1993. It was tested for a period of 6 months from August 1992. After some tuning, the algorithm even predicted about 90% of the bids correctly. On various occasions, Captains has proved to be a valuable tool for making accurate predictions and performing what-if analysis. It also creates shorter planning cycles and thus better control of strategic investment decisions. The KLM estimates that implementation of a strategic manpower planning system has led to 2% reduction of total manpower costs of pilots. The Captain's application shows us how machine learning techniques can be incorporated in commercial applications. At the moment, Syllogic is using machine learning techniques in a variety of environments, amongst others, planning and scheduling, database administration, and curriculum development. Using machine learning can lead to substantial savings and improvement of the quality of information systems.